is Joe Hammerman. We're doing trapped SAT problems. And we're going to go over, this is problem 30, which is the hardest one or the last one in the calculator for the answer. This problem is a huge time trap problem. The book way of doing the problem takes a lot of time. Now, the easiest thing to do is, we know this diagram is to scale. So if we draw a square like that, I don't draw it very well, but we draw a square like that, you can see that the hexagon is significantly bigger than the square, but it's not that much bigger. Now, if you work it out with your calculator, I believe 384 root 3 is like 665. Okay, so it makes sense. 256 makes the most sense. You might guess 192, but 256 is significantly less than half of the area of the hexagon. And also, it's also a perfect square, which might make it more likely, although 192 could be the square of something root 3. So that's possible. You definitely should be able to narrow it down to A and B and at least guess between the two of those. Because C, 64, what is that, about 110? And 16 root 3 is like 27 or something like that. So that just doesn't make sense at all, particularly D. So you can rule those out. And that's also, you could save this to the end, if you wanted to do it algebraically and just guess between A and B, and you probably would guess A. To actually solve the problem, you have to derive the formula for the area of a hexagon, or else memorize it. Now, most people do not have that memorized. Now, the way of doing this is, if you have a regular hexagon, this is 6 equilateral triangles. I mean, you know the central angle is 360 divided by 6 is 60. And the radii are congruent, so these are all 60. Now, you would need to find the area of an equilateral triangle. Now, it's easier if you have things numeric to do it to actually find the formula. But this is x over 2. Now, it's possible you know the 30, 60, 90 triangle, or you can find out with trig what this other side is. So I'm going to go over just the Pythagorean theorem method. So we have x squared over 2 squared, let's zoom out a little bit, plus h squared equals x squared. This is not x squared, it's just 1x here. So then this becomes x squared over 4 plus h squared equals x squared. Now you get all the x's on one side, we subtract. And we get h squared equals x squared minus x squared over 4. And then we get h squared equals 3x squared over 4. H equals root 3x over 2. You've seen that before. Root 3 over 2 is the cosine of 30 degrees, the sine of 60 degrees. And you could indeed figure out that that's a 30-60 triangle, and either do it by your knowing that, or this is calculator, you could get some kind of decimal answer with the calculator. It's certainly possible to do that way. And then your area for the hexagon is base times height over 2. That's the triangle area formula. You should know that. It's very basic. It's a good idea to study formulas and definitely know the triangle formula. And if you know the area of the hexagon formula, that would be good also. Possible to derive the area of the equilateral triangle also using Heron's law, which I'm not going to go into. But if you want to look that up and try that, and try some other derivations, that might be a good exercise. So our base is x, because this whole thing on the back here is going to be x. Also, because it's equilateral. So it's going to be x root 3x over 2 all over 2. Base times height over 2. So you get 1 over x squared root 3 over 4. And that's your formula of the area of the equilateral triangle. Here we can derive it if we don't memorize it. Again, this is a gigantic time trap to do this in real time. If you have time at the end, you can do that. If somehow you get time and a half or something like that because of some disability, you might be able to use that. So then the hexagon is going to be 6 equilateral triangles, so we multiply that by 6. So we have 6x squared root 3 over 4 equals 3x squared root 3 over 4, and that over 2. Now continuing with our laborious book method. And you see the problem here also, and you see how trappy this test is, because this is a gigantic time trap. Just go ahead and do this the book way. And so they're testing your problem solving ability. And you really don't want to do that. We would do 3x squared. I mean, if you memorize the formula for a regular hexagon, then it's not too bad. But times 384 equals 384 root 3, because we're given the area as that, so we set the area equal to the formula. Now we cancel here, and then we get x squared equals 384 times 2/3 is calculator. You can use the calculator. A third of 384 is 128 times 2 is 256. Now from here, you're just asking for the area of the square, so you just square that, get 256. Now another little time trap is we take the square root of 16, then we square that again and get 256 to be the area of the square. So that's our book method. But it's actually, when you see something crazy like that, you know, it's like, oh, this is great, find the area of a regular hexagon. It's like, find the side length of a regular hexagon given the area. It's too difficult, so the best way is to actually just make an educated guess by estimating the areas, rather than fall in the time trap, again, of using the book methods I'm showing you. Hi, this is my book, Advanced ACT Math. There are a lot of books that have 36 or 800 in their title. They're supposedly really advanced material, but they're not. This book goes into the hardest problems, makes them even more difficult, prepares you to get a top score on the exam, which is more difficult. It's very comprehensive, covers everything. Now, my website is here, and a lot of the material is available for free on the website. So please check it out first, and then see if you like it, you can buy the book.